Hello, my name is Vitour and I'm a virologist at the Laboratory for Animal Health in Maisons-Alfort near Paris. I'm particularly interested in our B viruses, a group of viruses which is important for animal health. This includes the African horse sickness virus, which is one of the diseases studied in the Wiedemann ID. African horse sickness is one of the 5 most dangerous animal diseases that could emerge in Europe. Its emergence would have devastating consequences for horses and the industry. The disease is transmitted by the African horse sickness virus. Its genome is made of several segments, very much like the influenza virus. Even worse, there are different types of this virus that can exchange genome segments, giving rise to even new, potentially more dangerous variants. The virus circulates mainly in southern and central Africa. However, at the end of the 20th century, major epidemics have been recorded in the Middle East, the Arabian Peninsula, Asia and Spain. The latest significant event is the emergence of the disease in Thailand in 2020, showing that the virus is a threat to most regions of the world. African horse sickness is an arbovirus, meaning that it uses arthropods like insects or ticks to transmit itself from a sick animal to a healthy one. In our case, it is a small biting midge called Culicoides. African horse sickness is seen as the equivalent of Ebola in humans. Once infected, more than 90% of horses are killed within 3 to 4 days. The disease causes hemorrhagic syndromes characterized by severe bleeding and inflammations. Close relatives of horses like zebras or donkeys can be infected but are generally much less susceptible to the disease. Zebras, for example, can carry this virus without symptoms. They are considered as the reservoir of the disease in Africa. The most devastating outbreak of African horse sickness occurred in Asia 65 years ago. It spread from Lebanon to India and resulted in the death of hundreds of thousands of horses. In some regions, horse populations completely disappeared. During the 60s and the 80s, African horse sickness reached the Iberian Peninsula. In 2020, the disease was reported in Thailand. As horse racing is very popular there, this episode has a huge economic impact. Within the Wiedemann ID consortium, we aim to understand the pathosystem of the African horse sickness. This includes the mechanisms of replication and transmission of the virus on multiple scales, from the molecular level to entire populations. Our objectives are better detection of the virus genome, better understanding of how it multiplies within its arthropod host, and improving the prediction of the risks and consequences of its emergence into Europe. In order to multiply within a cell, viruses have to reprogram cellular functions, a bit like a computer hacker. This involves connection between viral proteins and cellular proteins. In Wiedemann ID, we aim to identify these mechanisms using yeast-two hybrid technology, a methodology that has been recognized for years. This will enable us to draw up interaction maps and understand the cellular pathways required for infection. Another objective is to improve tools for sequencing the entire genome of the African horse sickness virus. To do this, we are using cutting-edge next-generation sequencing technologies, which offer incredible reading capabilities for genomes of all kinds. Finally, we will use mathematical models to predict the risks that the African horse sickness emerges and spreads in Europe. Nevertheless, the disease remains a major threat for horses, especially because global trade and global warming favor the spread of the virus. Many improvements are still needed in the management of African horse sickness. For example, controlling the arthropods that transmit the disease remain largely ineffective. Also, current vaccines have a number of drawbacks and cannot be used in Europe. To this aim, the Wiedemann Consortium will contribute to better detect, prevent and understand the disease, in order to improve control measures.